Now in the sixth class of interference, we have to study determination of wavelength of monochromatic light using Newton's ring. It is 10 mark question. So first you have to explain apparatus. See, there is a plano-convex lens placed over a glass plate. These two are separately cleaned first and kept one ring-shaped box such that it's a convex surface touching the glass plate. And S is the source of monochromatic light, say sodium source. Then the ray travels, and in their path exactly above this plano-convex lens, a glass plate making an angle of 45 degrees is placed. And the ray after falling here, they suffers total internal reflection and travels towards the plano-convex lens. Then after falling on the plano-convex lens, they gets reflected back. And if this reflected light is observed through the travelling microscope, for to recollect your memory, I have shown the travelling microscope here. Through travelling microscope, so concentric dark, bright rings are observed. They are called as Newton's ring. At the center there is a dark ring. We know that the diameter of the dark ring, it is just you have studied, destructive interference is equal to 4 n lambda into r. So 4 n lambda r, where r is the radius of curvature of this plano-convex lens. The plano-convex lens is selected in such a way that it has a large radius of curvature, nearly 100 centimeters. So r is the radius of curvature of this plano-convex lens. Lambda is the wavelength of this sodium source which has to be determined, and n is the number of fringes. That means it is first fringe dark, second, third, fourth, etc. Then its next fringe. So assume that this is n fringe, and again this is p fringe. The same equation can be written as for p fringe, dn plus p whole square is equal to 4. In place of n, it is n plus p lambda r. So call this equation as 1, call this equation as 2, and your d square n plus p minus dn square, this minus this, you are going to get this as, it is 4 n plus p lambda r minus 4 n lambda r. 4 n lambda r, 4 n lambda r get cancels. You are going to get this is dn p whole square minus dn square is equal to 4 p lambda r. 4 p lambda into r, or this is lambda is equal to, you want what is lambda? Lambda is equal to dn plus p whole square minus dn square divided by 4 p r. Call this equation as 3. Using this equation, we have to find out lambda. Then how to find out lambda? So this traveling microscope, by rotating this head, this carriage is brought exactly at the center. Means at the center is the 0th ring. Then the cross wire of this traveling microscope is it should be tangent to this line. This is 1, 2, 3, 4. Like this, it has to move up to 22nd ring. One side. Say it is right side. Then you reverse it. Focus it on 21st, 20th and 19th. Now I have brought it on 19th. Note down the reading on this horizontal scale. Then similarly it is tabulated by bringing it on 18th. Then next is 17th. Like this, you have to focus it on the 5th dark ring. Continue this moving on the same direction. So focus it on the 5th dark fringe on the other side, this side. Then move it up to 19th. What you have done is, first you have focused on the 22nd, you have not taken any reading. Then that cross wire is brought by rotating this on the 19th. Then counted started from 19th to 5th. Then move it on 5th to another 5th, don't take any reading. Then 5th, 6th, 7th, 8th, 9th, like this. You have to bring it on 19th. Then you plot the graph by taking dn square along y-axis, corresponding number, means 18th, 19th, 20th, 5th, 6th, 7th, 8th, like this, along x-axis. Then here this is nth ring, here it is pth ring. Then take the slope of this AB upon BC. What is AB upon BC? This is AB. That will give this dn plus p whole square minus dn square, and this distance is p divided by p. So totally slope of the straight line, you are going to get the straight line. Slope of the straight line will give your d square n plus p minus dn square upon p. Therefore your lambda is equal to, it is slope divided by 4r. So using this equation, you know radius of curvature is given, it is large radius of curvature about 100 centimeter, and you are getting this P and dn plus P minus dn square. So this is AP and this is P. So if you substitute, you are going to find out what is the wavelength of the monochromatic source. Let us solve some examples. See in your notes, page number 16, 5 marks. First example is a transparent plate of thickness 10 raised to minus 3 centimeter. That means thickness is given. It is 10 raised to minus 3 centimeter. Is placed in the path of one of the interfering beams of biprism experiment using light of wavelength. So lambda is 5000 angstrom unit. To write it in centimeter, it is 5000 into 10 raised to minus 8 centimeter. If the central fringe shift by distance equal to the width of 10 fringes, that means x is equal to 10 beta width of 10 fringes, calculate refractive index mu. So you see the second formula, that is T is equal to xd upon d into mu minus 1. So your mu minus 1 is equal to x into d upon d upon t. Call this equation as 1. You also know that the first formula is beta is equal to d lambda upon d. Then d upon d is equal to beta upon lambda. Then this is d upon d. D upon d is equal to lambda divided by beta. Your mu minus 1 is equal to, so x is 10 beta divided by t is 10 raised to minus 3 into d upon d. D upon d is lambda divided by beta. So beta get cancels. Your mu minus 1 is equal to, this is lambda is 5000 into 10 raised to minus 8 into 10 raised to minus 4 plus 4. This is 10 raised to plus 3 and this one is 10 raised to plus 4. You will going to get this as 0.5. Therefore, your nu is equal to 1.5. See on page 17, Problem 3. In biprism experiment, at a certain position of the eyepiece, the fringe width obtained is 0.2 millimeter. So let at d meter, fringe width obtained beta is equal to 0.2 millimeter. When the eyepiece is moved away by 0.5 meter, that means your d dash is equal to d plus 0.5. It has moved. Fringe width becomes 0.3 millimeter. Beta dash is 0.3 millimeter. If the distance between two coherent sources is, if d is 3 into 10 raised to minus 3 meter, calculate wavelength of the light used. Now in the first case, beta is equal to d lambda upon d. Call this equation as 1. Then in the second case, the distance has been increased, which is d dash. Therefore, second case, beta dash is equal to d dash lambda upon d, or your b dash is equal to d dash is what? D plus 0.5 into lambda upon d. Call this equation as 2. Divide equation 1 by 2. Beta upon beta dash. This is d lambda divided by d into, this is d divided by d plus 0.5 lambda. D cancels, this lambda and this lambda. So what is b upon b dash is equal to d upon, it is d plus 0.5. Then what is that b upon beta dash? Your b upon beta dash is, beta upon beta dash is, beta is 0.2 upon 0.3, that is equal to d upon d plus 0.5. You can write this as 2 by 3 is equal to d upon d plus 0.5. Cross multiplication. This is 2d plus 1 is equal to 3d. Then 3d minus 2d is 1. Therefore, your d is 1 meter. Substitute these values in equation 1. Your beta is equal to d lambda upon d. Your d is given. How much? 1. Just you have calculated this is 1. Then wavelength is asked upon small d is given 3 into 10 raised to minus 3. So beta is also given 0.2 millimeter, 0.2 into 10 raised to minus 3 it is. Therefore, your lambda is 3 into 0.2 is 0.6, 10 raised to minus 6, or this is 6000 into 10 raised to minus 10. Answer is 6000 angstrom unit. See the fifth example. In Newton's rings experiment, diameters of the 5th and 15th are 0.336 into 10 raised to minus 2 meter and 0.590 into 10 raised to minus 2 meter. Find the radius of curvature of the plano convex lens. You ask what is R. If wavelength of the light used is lambda is 5890 angstrom unit, or this is 5890 into 10 raised to minus 10 meter. You have to use the third formula. You know this lambda is equal to dn plus p whole square minus dn square upon 4pr. Your r is dn plus p whole square minus dn square, that divided by 4p lambda. Then dnp is this one, n is 5 plus 10. Then dn square, p is here 15 minus 5. This is p. Then substitute this. R is equal to, this is 590 into 10 raised to minus 2 whole square minus 0.336 into 10 raised to minus 2 whole square divided by, it is 4. P is 10 into lambda is 5890 into 10 raised to minus 10. Then if you simplify this, you are going to get this as 0.92 meter. You simplify this using calculator, you are going to get it as 0.92 meter. Then see the seventh one. A biprism is placed at a distance of 0.05 meter from a slit. Biprism is placed at a distance of 0.05 meter from a slit. Means A is given. Is illuminated by sodium light. The width of the fringes obtained on the screen 0.75 meter from the biprism. 0.75 meter from the biprism means it is B. Beta is how much? 9 into 10 raised to minus 4. 9 into 10 raised to minus 4 meter. What is the distance between coherent sources? D is what? Given lambda is 5890 angstrom unit. This is 5890 into 10 raised to minus 10 meter. Then you have to first calculate what is D. Your D is A plus B. What is A plus B? 0.0 plus 0.75. This is 0.8 meter. And you know that first equation, beta is equal to d lambda upon d. From this your d is d lambda upon beta. So capital D is 0.8, lambda is 5890 into 10 raised to minus 10. Your beta is 9 into 10 raised to minus 4. Then if you simplify this, you will going to get 0.52 into 10 raised to minus 3 meter or 0.52 millimeter. So similar problems are there in the same phase. You calculate yourself. So this completes your first chapter of interference.